Wednesday the 27th of January, we're going to be looking at recurring decimals. We're going to be changing a recurring decimal into a fraction. This is a non-calculator task. First of all, what is a recurring decimal? Well, if we start actually looking at the opposite, a terminating decimal, if something terminates, it stops. So these are just examples of decimals that stop. They are terminating. They can be expressed as fractions, but also these decimals can be expressed as fractions because they are recurring. They are repeating decimals. So 0.1 recurring, 0.3 recurring, 0.12 recurring, and so on. There are two different ways to write recurring decimals. So you'll notice if I just zoom in here, 0.111 ... suggests that the 1 repeats. But what we tend to write and what the calculator will write is 0.1 with a dot above it. Similarly here, if the 3 repeats, we put a dot above the 3. Here we have two separate digits repeating, 1, 2, 1, 2, 1, 2. So we'll write 0.12 with a dot above both digits. But be careful with the next type, 0.234, 234, 234, and so on. To write it with dot notation, it's 0.234 with a dot above the 2 and the 4, not in between. So the dot signifies where the recurring digits start and where they end. 0.512, even though the 5 is on its own and it isn't part of the repeating digits, it is still a recurring decimal. And to write it with the dots, it's 0.512 with a dot above the 1 and the 2. And here's a slightly more complicated one. Doesn't look to be recurring from first glance, but you'll see here we have 251, 251, ... So we put a dot above the 2 and the 1. So all of these are examples of, just random examples of recurring decimals. Now what we're going to do is we're going to show you a method to change these into fractions. So let's look at the method for changing a recurring decimal to a fraction. So a question might give you your recurring decimal in this form, 0.1 with the dot, 0.5 with the dot. The first thing we're going to do is we're going to let x be equal to our recurring decimal, but we're going to write it, in this case x is equal to 0.111 ... So we'll write a few of the digits that are repeated. In this case, let x equal to 0.555 ... So these two questions are almost identical. They will have the identical method. So first step, calling it x. Second step, well, if that's x, what I'm going to do is multiply it by 10. So if we have 10x, well then multiplying x by 10 is not 0.111, it's 1.111. And taking x and multiplying on this right hand side, multiplying by 10, will not give us 0.55, it'll be 5.555. So two questions, we're multiplying both by 10. Now the reason why we're multiplying x by 10 is because we want to do a subtraction. And we want to do a subtraction such that the digits after the decimal point disappear. So on the left hand side here, we want to do a subtraction so that all the 0.111 goes away. And on the right hand side, we want to do a subtraction so that the 0.555 goes away. Now all I have done here is multiplied by 10 as I've discussed, and underneath it I've just written x again. You don't have to write it underneath, but the reason why I'm doing it is because I'm doing a subtraction. I'm doing big take away small. So here's our 10x on the right hand side, and we're doing a subtraction here. That's just our original x. So back to the left hand side, we have 10x, take away x, and that gives us 9x. Now the key part here on the right, just here, is we have 1.1 recurring, subtract 0.1 recurring. Because you have these ones here and here, they cancel out. And really what you're doing is 1 take away 0 to get 1. From there, just a bit of basic algebra. Divide 3 by 9, x is 1 over 9. The equation on the right hand side, we are doing 10x, subtract x, so that gives us 9x. We are doing 5.5 recurring, subtract 0.5 recurring, And the whole point of it is to get rid of those 0.5s. So essentially all we're doing is 5 take away 0 to get 5. Bring your 9 over to the other side. X is 5 over 9. So for one digit recurring, 0.1, 0.5, 0.7, it's always going to be over 9. Moving on to the next type, where we have 2 digits recurring. So the question on the left hand side is 0.23, where the 2 and 3 recurs. Very similar here, 0.17, where the 1 and 7 recurs. Same as before, just call it X, but write it out with a few of the digits recurring. Now, we're not going to multiply it by 10 anymore. We're going to multiply it by 100, because we want 2 and 3 to both jump over to the left of the decimal point. And on this one, we want 1 and 7 to both jump over to the left of the decimal point. The reason for this is because of the subtraction that we're going to do. We need the digits after the decimal point to match up. They need to be 2323 and not 3232. So, question on the left here, because we've multiplied by 100, we now have 23.2323. And then just subtracting our original X, these go away. So we have 100X, subtract X gives us 99X. 23, subtract 0 gives us 23, and divide through 23 over 99. Question on the right, because we've multiplied by 100, we have 2 digits recurring, so we multiply by 100. So then we have 17.1717. When we do 100x, subtract x, we get 99x again. 17 subtract 0 gives us 17, and divide through by 99. But sometimes not all the digits are recurring. So I've written medium difficulty here, but it might be hard. So just look at those two questions. They're both going to be set up in exactly the same way. We have 0.145 with the 4 5s recurring, and 0.721 with the 2 1s recurring. So each of these has a little problem here. The question on the left has a digit that doesn't recur. The question on the right has a digit that doesn't recur. The first step, as with all the questions so far, just call X our decimal and write out a few of the recurring digits. The first step, we're going to do 2 multiplications here. And the first multiplication is, we want to move that non-recurring digit out of the road. So this 1 and this 7, we'll have to move them over. And because we're moving one digit, shifting one digit, we have to multiply by 10. So 10x moves the non-recurring digit out of the way. 10x moves the non-recurring digit out of the way. And we're done with x now. We don't use x anymore. Instead, what we want next is not only the 1 on the other side, but a 4 and a 5 as well. So we're not going to multiply by 10 to get them all over. We're not going to multiply by 100 to get all those over. We're going to multiply by 1,000 to get those 3 digits over. And on the question on the right, we need 3 digits over to the left hand side, so we multiply by 1,000. You might be more comfortable in thinking, well, how do we get from 10x to 1,000x? Just times it by 100, moves the 2 digits over. But the whole purpose of this is to have the digits after the decimal points identical. The reason why we need them identical is because when we do a subtraction, they all need to disappear. So when we do a subtraction, the digits after the decimal points need to disappear. Now what are we subtracting? Well, the question on the left hand side, we have worked out 10x and 1,000x. These are the two values that have a 4545 after the decimal point. So we're going to do 1,000x subtract 10x. So these cancel. And on the right hand side, we're going to do 1,000x subtract 10x so that these digits cancel. 1000, take away 10, 990. 145, take away 1, 144. So our answer is 144 over 990. 1000, take away 10, 990. 721, take away 7, 714. So our answer is 714 over 990. So for these harder questions, if you have a digit that is not recurring, you need to multiply by 10 to get that digit across, and then start again. For these digits where you have these questions where you have two digits recurring, you need to multiply by 100. And the basic ones, if you have one digit recurring, you multiply by 10. And then do your subtractions so that your digits after the decimal point disappear. And that is all there is to converting between a recurring decimal and a fraction.